All right, so now we're going to finish looking at the geometric approach to vectors. So we're on section 9.3, day 2. And again, vectors, the geometric approach. So we covered the basics of that in the last video. Now we're going to talk about two specific kinds of problems. We talked about what happens when you have two forces acting on an object when the two forces are acting at 90 degrees to one another. Now we're going to talk about what happens when you have a situation like this, where you have one vector, let's change that color, one vector and then another vector, both working on an object. But now this angle between the two vectors, vector g and vector f, is not 90 degrees. Now it's going to be some angle, we'll call that angle alpha. And so they're going to tell us that the magnitude of f is equal to 3 newtons. The magnitude of g is equal to 7 newtons. And they're going to tell us that alpha, the angle between them, is going to be 70 degrees. So this is not drawn to scale. This is a generic picture. And so what happens is, if we go tip to tail or we do the parallelogram method, let me move this stuff over a little bit because it's going to be in the way. Our resultant is going to be over here. And so what we're interested in is we are interested in the magnitude of the resultant and the direction of the resultant. The direction of the resultant is going to be this angle here, which we'll call theta. So alpha is the angle between the two vectors, but theta is the direction for the resultant, which I'll call r. So the first thing is that I'm going to draw a more accurate picture. So we have F, which is 3 newtons. Let me switch colors again. We have G, which is 7. So we have something that's roughly looking like this. And so our resultant is basically going to be out here somewhere. And this big angle here, we know is 70 degrees. The key to this whole thing is the fact that we have a parallelogram. See, the problem is we don't have a right triangle over here, so we cannot use the Pythagorean theorem. We do know this is 7 newtons. We do know this is 3 newtons, which makes this 7 and this 3. But we don't have a right triangle. We cannot use the Pythagorean theorem. We cannot use tangent. What we can do, though, is go back to geometry and remember that adjacent angles in a parallelogram, because of the parallel lines cut by a transversal, add up to 180 degrees. Therefore, if this is 70, 180 minus 70 gives us 110 degrees. And what we're now going to do is we're now going to take a look at this triangle here. Okay? That's the triangle we want to stay focused on. What we're going to do is we're going to look for R. Notice we have side angle side information. That means we can use law of cosines on it. And by using law of cosines, we know that R squared is equal to 3 squared plus 7 squared minus 2, 3, 7 cosine of 110 degrees. And so R squared is equal to, go to my calculator, make sure I'm set to degrees, which I am. So we have 3 squared plus 7 squared minus 2 times 3 times 7 times cosine of 110. That's R squared, 72.3648, and then we take the square root of that, is about equal to 8.5. So our magnitude then is about 8.5 newtons. Sorry, should have put it here. All right. The last thing we have to do is we have to find the direction, which is this angle here. Again, we cannot use tangent because we don't have a right triangle, but what we can use now is law of sines. Now, technically we're using, we're going to use, we have to use these two together, and so whether I use this side or this side, I'm using angle side information, which gives rise to the ambiguous case, but we really don't have to worry about that because we already have an obtuse angle in here. So that shouldn't really be the problem. But to stick with what I told you guys before, it's safer to use law of cosines again. So I'm going to do 7 squared equals 3 squared plus 8.5 squared minus 2 times 3 times 8.5 times cosine of theta. So cosine of theta is going to be equal to, it's going to be 7 squared minus 3 squared minus 8.5 squared over negative 2 times 3 times 8.5. Once I get cosine theta by itself, we have a formula that does that for us, but otherwise you can just work out the numbers and move everything over like we did before. I'm just making this a little bit quicker to keep the time down on the video. So 7 squared minus 3 squared minus 8.5 squared equals, and that's going to get divided by parentheses, negative 2 times 3 times 8.5. That's cosine of theta, and so then inverse cosine of that is going to give us theta is about 50.8 degrees. So we know that this is our direction. We know that this is our magnitude. So that's how you do these problems when the two vectors, the two forces, are not acting at 90 degrees to one another. So you use the law of cosines in that lower right triangle after you do 180 minus the angle between the two vectors. Okay, I have one last example. It's pretty quick. And this is when now they give us the magnitude of a vector. So now we have some vector v. What we want to do is we want to break this thing into its x and y component vectors. We want to know what would be the horizontal component and what would be the vertical component for this vector. So this is vector v. And they tell us that the magnitude of v is equal to, let's say, 12 newtons. And they tell us the direction vector. They tell us that theta is equal to 40 degrees. We want to know what is the magnitude of v in the x direction. So I'll call that vx. And we want to know what is the magnitude of v in the y direction. I'll call that vector vy. I want to know how strong this force is and that force is so that when I add those two forces together, we get this resultant. And it's very easy to do. It turns out that Vx is equal to the magnitude of v times, since we're going in the x direction, it's cosine of theta. Remember from our unit circle, cosine is x, sine is y. That's holding here as well. And likewise, Vy is equal to the magnitude of v times sine of theta. And so you just use these two formulas in your calculator and you get your answers. So this is going to be 12 times cosine of 40 degrees. This is going to be 12 times sine of 40 degrees. And so notice those are not unit circle values. 12 cosine 40. If they were, we would use the exact value. So I have about 9.2. So this is about 9.2 newtons. And 12 sine of 40 is going to be 7.7. So this is about 7.7 newtons. So there's your vertical component, there's your horizontal component of this vector. That's it. So nice and short and sweet. those are really the only two kinds of problems you guys are going to be tackling on this next assignment.